Okay, this is the third part of the review guide that we got before break, the Unit 3 section on Unit 3. So the first question is asking us to name all the valid postulates, theorems that can be used to prove that two triangles are congruent. So we have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. We do not have angle, 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 and side, side, angle. These are the two we do not have. 22, for the following triangles, determine whether they're congruent and by which postulate or theorem. If they are not congruent, explain why not. Okay. Well, the first one, we have two pairs of congruent, two corresponding sides that are congruent. We also want to look for vertical angles of shared sides. There is a shared side. So by the reflexive property, we know that that piece is congruent to itself. So now we have how many corresponding parts that are congruent? We have three corresponding parts that are congruent. So we want to cover up one of the triangles, side or angle, that's a side, side, and side. So we have side, side, side. Well, if we look back at 21, side, side, side is one of our postulates that shows that the two triangles are congruent. So by the side, side, side postulate, those two triangles are going to be congruent. Okay. If we look at the one below it, again, we want to look for shared sides or vertical angles. So before we do that, we notice we have two sets of angles that are congruent, two corresponding sets of angles that are congruent. We're looking for three pieces, so we look for shared sides or vertical angles. We do have a shared side. Okay, so by the reflexive property, that side is going to be congruent to itself. Okay, and then we can look at one triangle, side or angle. We have an angle, a side, and an angle. So by the angle, side, angle postulate, right, which says that if we have two corresponding angles that are congruent and the included side is congruent, then by the angle, side, angle postulate, we can conclude that the two triangles are congruent. If we go to the upper right here, okay, those are perpendicular lines, so we can put a right angle in both of them. We know by the right angle theorem that right angles are congruent. We also know that we have two corresponding sides that are congruent. So we have three corresponding parts that are congruent. So if we cover one of the triangles up and we look at the order, we have side, side, angle. But also in number 21, we noticed that side, side, angle was not one of the theorems or postulates that we can use. But since we have right angles, we can use the hypotenuse leg theorem because we have right triangles. So since we have right angles, we have right triangles. And so we can use hypotenuse leg. Hypotenuse leg theorem requires three things, three conditions for it to be true. One, we need right triangles. We need a pair of legs that are congruent. And we need the hypotenuses to be congruent. Okay. Well, do we have right triangles? A right triangle is defined as a triangle that has a right angle. So since we have a right angle, we have a right triangle. So we can check that off. Okay, do we have a pair of legs? Well, yes. So again, this is a leg, this is a leg, and the side opposite the right angle is the hypotenuse. So leg, leg, hypotenuse. We don't need both sets of legs. We only need one set of leg to be congruent. And the dash mark tells us that this set of legs is congruent. So that's good. Check. And then our hypotenuse is congruent. Yes, they are. The sides opposite the right angles are congruent. So we have all three qualities checked off, so we can use hypotenuse leg as our answer. Okay. Then the fourth one, we have two corresponding parts that are congruent. We have a pair of angles that are congruent and a pair of sides that are congruent. That gives us two. We need three. So we want to look for shared sides of vertical angles. Again, we have shared sides. Okay, so those two sides are shared. So by the reflexive property, they are. Okay. Right. So again, we can name, as we've done before, we can name the first one however we want. So I'm just going to go in order, RQS. RQS. I'll write it better. RQS. We could have written it RSQ, QSR, QRS, SQ, SQR, SRQ. So there's 6 different ways we could have written it. It doesn't matter which of those 6 ways we write the first one, but we have to match the other one up based on its corresponding parts. Okay. So R is going to correspond to which part? The easiest way to do that is look at the angle. Which angle corresponds to angle R? Well, it's got the one arc. So which angle and the other one has the one arc? It's angle S. Okay. We went to Q, which has the 2 arcs. So SQRQ is going to correspond with SD. So we're going to go to SD, and then we're going to go down to S. Okay, and D goes down to C. So again, there's 6 different possible answers. Okay, it doesn't matter how you name the first one, as long as you name the second one in the correct order based on its corresponding parts with the first one. So for example, if we name this one QRS, our answer would have been, so QRS, our answer would have been DSC. Okay, and then there's 4 more possible answers. Okay, the next one, a little more tricky because it's contorted around. Let's pick the top one in the order we want. Okay, how about SRQ? Okay. So S has 2 arcs, so we got to start with the angle with 2 arcs, which is going to be C. Then I went to R, which has the 3 arcs, so it's going to A, CA. And then I went to Q in the middle, which has the 1 arc, so it's going to be Q. Okay. Just for example, if we did QRS, okay, that's going to be congruent to QAC. Again, doesn't matter as long as we write, and then there's 4 other options. So it doesn't matter how we write the first one as long as the second one is the corresponding parts, the corresponding triangle. Okay, using the triangle from above left, complete the following congruent statements. Okay, so okay, angle QRS. So we could look up here, QRS. So this angle right here is going to correspond to what angle? Well, it's got 1 arc, so it's going to correspond with angle S. So DSC. DSC. CDS has 2 arcs, so it's going to correspond with angle. CDS is going to correspond with SQR. Angle SQR. DS has the 1 hash mark, it's going to correspond with QR. RS is going to correspond with SC. And then DC is going to correspond with QS. Okay. Scroll down to 25. What additional information would be needed to prove the triangles are congruent by angle, side, angle? So angle, side, angle is going to have 2 corresponding angles that are congruent, and then an included side, meaning the side between them. Okay. We had a question like this on our test. The first thing we need to look for is shared sides and vertical angles, because we know vertical angles are congruent and we know shared sides are congruent by the reflexive property. We do have a shared side. Look at that. How surprising. FG is congruent to FG by the reflexive property, or you could say FG is congruent to GF by the symmetric property. We now have two corresponding parts that are congruent. We have an angle, right? Angle KFG is congruent to angle HGF. And we know that FG is congruent to GF. Okay. So we have an angle on the side. Now we need another angle, and we need it such that the side is between the two angles. So if we have an angle and a side, here's our two choices. We put the angle over here, it's not going to be with the side is not going to be between the two angles. So we have to put our angle here, right? Angle HFG. What corresponds to angle HFG? Well, it's going to be KGF. And that is our answer. We now have angle, side, angle. The side that's between the two congruent angles. We knew that FG was congruent to itself by the reflexive property or the symmetric property. If you say FG and GF, we were given one set of angles. Okay, so what extra information do we need? What additional information would we need to prove that they're congruent by angle, side, angle? Well, we need that second angle. We need the angle to be HFG and KGF, because the side needs to be in between, it needs to be included between the two angles in order for it to be angle, side, angle. Otherwise, it would be angle, angle, side. 26, moving along. Had a question like this on the test. Okay. So you are given that PQR is congruent to LMN. Okay. The corresponding sides. So again, if we need to, we can draw it out. We don't necessarily need to, but we can draw it out. PQR and then LMN. Okay, we know these are congruent because we've drawn them in the exact same way. Okay. We also know from the name. So let's look at the side. PQ is going to be congruent to L, M. Okay. And if you can't do it, you can do it just from the name, the congruent statement. The congruent statement gives you all the information you need, but if you're confused or you're not comfortable with that, draw it out. No reason not to draw it out. Okay. So PQ is the first two, LM is the first two in the next one. Then we have QR, which is the last two, and MN, which is the last two. So we'll say QR is congruent to MN. If you said RQ is congruent to NM, that's fine too. QR, MN. All right, and then our third set is PR, which in the name is the first and the last. That's going to be congruent to LN. Angles are easy. So angle P is congruent to angle L. Angle Q is congruent to angle M. And angle R is congruent to angle N. Again, if you can't get that from the diagram, from the congruent statement, which is just saying it in order, draw it out and we can see P and L, Q and M, R and N. Okay. We could also name it, instead, this is just an alternative name. We could say QPR is congruent to MLN. Well, let's do it this way. Okay. PQR is congruent to angle PQR, angle PQR is congruent to angle LMN. Okay. Angle QRP is congruent to angle, so we want QRP, so it's going to be MNL. And if you're not comfortable with that, again, PQR is congruent to LMN. QRP is congruent to MNL. Okay, and then here we have RPQ. RPQ, so the last one and then the first two is going to be congruent to the last one, angle NLM. If we check it, angle RPQ is congruent to angle NLM. Okay. So if you want to write it that way instead of with that, that's fine. Okay. Draw a picture to solve for x in the following problem. Triangle EFH is congruent to triangle DPS. The measure of angle E is 5x plus 6. The measure of angle D is 2x plus 33. And the measure of angle S is 2x minus 6. So draw it out. Even if it didn't say draw it out, you should still probably draw it out. Okay? Just to be safe, know what you're doing. EFH. Draw the other one in the same order. Okay, DPS. Looks like it's Edsel Ford High School and Dearborn Public Schools. Tells you those Edsel people probably dominate the process. I don't know what I'm saying. I'm just making stuff up. All right. So angle E is 5x plus 6. Angle D is 2x plus 33. And angle S is 2x minus 6. Okay. Well, we know that angle E is congruent to angle D. Right? So we know the measure of angle E equals the measure of angle D. The measure of angle E is 5x plus 6. The measure of angle D is 2x plus 33. And then we can solve for x. Subtract 2x from both sides. 3x plus 6 is going to equal 33. Subtract 6. 3x equals 27. Divide by 3. We get x equals 9. Okay. Substitute back in just to check. 5 times 9 plus 6. So 5 times 9 is 45. 45 plus 6 is 51. 2 times 9 plus 33. 18 plus 33 is 51. So we know we're correct. Oh yeah, 4 left. All right. This looks like an interesting problem. Okay, and again, just reread this question. Make sure it just wanted you to find x, so we're good. It didn't want you to substitute in for s or anything like that. All right. Find the missing angles. Okay. Well, the first thing we notice, or first thing I notice, is that you have a couple of isosceles triangles. Okay. We have this isosceles triangle right here. If you want to rewrite it out, that's fine. Okay. We know this is 82, and this is E. Okay, it's the middle one. kind of making a mess of it. Okay. Well, it's an isosceles triangle, so we know by the isosceles triangle theorem that the two base angles are going to be congruent. They're going to have the same measure. Those are the angles opposite the two congruent sides, so we know this is also going to be 82. Okay. And then by the triangle sum theorem, we know 82 plus 82 plus e is going to be 180. 82 and 82 is 164. Plus e is 180. Subtract 164 from both sides. E is going to be equal to 16. Okay. E is going to be equal to 16. So let's see. We have A, B, C, D, E, and F. So we know E is 16. Okay. We have linear pairs. Okay. So we have some linear pairs here. Right. We said this was 82. We know these two form a linear pair, B and 82. We said it was 82. So this is where B is, right? So B is over here. These are a linear pair. So we know 180 minus 82 is going to give us 98. So we know B is 98. Well, we have this triangle. We know this is 25. Okay. This one's 25. So we know A plus 98 plus 25 is going to equal 180 by the triangle sum theorem. Again, if we need to zoom in, it looks something like this. We found that they're telling us that's 25 and this is A, and then this was B, and we found B to be 98. So we add the three angles up to 180. Okay. So A, 98 plus 25 is going to be 123. Subtract 123 from both sides. A is going to be 57. Okay. A little confusing, but the other thing we notice is that we have another isosceles triangle. The outside one is an isosceles triangle. So if we eliminate the middle, or just do the big one, okay, whoops, we know that this is 57 and this is isosceles. So if this angle is 57, this one is also going to be 57 by the isosceles triangle theorem, which tells us the two angles opposite the congruent angles are going to be equal. Their measures are equal. Their angles are congruent. Okay, the base angles. So this is also 57. Okay. So that is D. D is 57. C, we can also do a linear pair. So 180 minus 82 gives us 98. So C was also 98. We found A to be 57. The last one we have is F. And we found D now, right? D is 57. So 57, 98, and this is F. And we know E. We found E to be 16. Okay. So again, same as this one, we would have F plus 98 plus 57 equals 180. Okay, so F plus 105 plus 50 is 155. Subtract 155. F is going to be equal to 25. Okay. F is going to be equal to 25. And those are going to be our answers. We can check. One way to check is this triangle has to add up to 180. So if this is 57 and 57, That's going to be 57 plus 57 is 114. So this one is going to have to be 66. Okay, so 25 plus E plus F has to equal 66. So 25 plus E plus F has to equal 66. 25 E is 16. F is 25. 25 and 25 is 50. 50 plus 16 is 66. So there's just a way to check our answer. It's an interesting problem. 29, we've had pretty much the same thing on a test. Okay, it was one variation, one slight variation. So it's telling us this outside angle is 114. So we have a linear pair. So 180 minus 114 is going to give us 66. 66. Well, we have an isosceles triangle. So by the isosceles triangle theorem, the two angles opposite the congruent angles are going to be congruent themselves. Their measures are going to be equal. The base angles of an isosceles triangle are equal. So this one is also going to be 66. Okay, if we make this, let's say y, we know that 66 plus y has to equal 180 by the triangle sum theorem, which says the three interior angles of a triangle add up to 180. So we have 66 plus y is 180. That's going to be 132 plus y is 180. Subtract 132. Y is going to equal 48. 48. But we have a right angle. We know right angles are 90 degrees, so we know we can use the complementary angles. What was I going to say? We can use the angle addition postulate because these two angles have to add up to 90. So we can do 90 minus 48, which is going to be 42. So we know that this angle here has to be 42 because these two angles are complementary. They have to add up to 90. We also know, again, we have another isosceles triangle. So opposite the two congruent angles, the two congruent sides, the two congruent angles are going to be congruent, or their measures are going to be the same. So if this is x, this one is also going to be x. Right? Not 42, but x. Some of you made the mistake of 42 and 42. It's x and x because it's opposite the two congruent sides. The base angles are the same. And these are the two base angles, opposite the congruent sides. Okay, triangle sum theorem, all three of those angles are going to add up to 180. So x plus 42 is going to equal 180. 2x, combine like terms, 2x plus 42 is 180. Subtract 42 from both sides. 2x is going to equal 138. Divide by 2. X is going to be equal to 79, maybe 69. $69. And they just want you to find x. Yep. It's a good problem. We've seen it before, though. Should be okay. Okay, now we have two proofs that end it. Okay. Complete the following proofs. Rn is perpendicular to AG. A is the midpoint of Rn. Prove that GRA, so triangle GRA, is congruent to triangle GNA. Okay. Well, we can do this. So 2 givens. Again, I don't like how the order they put them in. That's fine. Rn is perpendicular AG, that's given. And then we have A as the midpoint of Rn, that is given. They make it a little bit complicated in how they organize it. I don't like that, but that's fine. Okay, so what do we look for? Right, so right now we have 0 corresponding parts that are congruent. We don't have any. So let's use what's given. I mean, our first step is to look for shared sides or vertical angles. But again, I don't like the order. So let's just follow our process. Look for shared sides or vertical angles. Well, do we have any shared sides or vertical angles? Yes, we do. We have a shared side. So AG is congruent to AG by the reflexive property of congruence. It's a lot of order, but we wrote our givens. We look for shared sides, vertical angles. Okay, we now have 1 corresponding part that is congruent. Now we want to use our givens. So let's use our first given here, which is that we have perpendicular lines, Rn and our segments Rn and AG. Well, the definition of perpendicular lines says that where they intersect, they form right angles. So where does Rn intersect AG? Rn intersects AG right here. So we know we have right angles. So angle RAG and our angle NAG are right angles. What do we know about right angles? We know right angles are all congruent. They're all 90 degrees. The measures are all equal. Since the measures are all equal, they're congruent. So by the right angle theorem, which says all right angles are congruent. So we know angle RAG is congruent to angle NAG. Okay. So we wrote our givens. We looked for shared sides or vertical angles. We used our first given. Now we have 2 corresponding parts that are congruent. We still need a third. Luckily, we have the other given, so let's use our other given. If A is the midpoint of Rn, we're looking for congruent segments. So A is the midpoint, meaning it splits it in half. It splits it into 2 congruent pieces, 2 congruent segments. So those congruent segments are going to be RA and NA. So RA is congruent to NA by the definition of a midpoint. Definition of midpoint is a point on the segment that splits the segment into 2 congruent segments, 2 congruent pieces. Splits the big one, Rn, into 2 congruent parts. We now have 3 pairs corresponding parts that are congruent. So we can look to try and use one of our postulates, right? Side, 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 angle, angle, side, angle, 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 side, or a hypotenuse leg. So let's write it in. Cover one triangle up, side, angle, side. So it's the side or an angle, it's a side. This is the side or an angle, it's an angle. This is the side or an angle, it is a side. So we have side, angle, side postulate or theorem, or side, angle, side, it's fine. Whatever you think is good or your teacher thinks is good. And I think side, angle, side is fine. Last one. Given that XY bisects angle WYZ, we're also given that angle WXY is congruent to angle ZXY. So step 1 from our proofs, let's write our given. So they've written our first given here. Okay, let's write our second given. Angle WXY is congruent to angle ZXY. Let's fill it in. WXY is congruent to ZXY. Okay. So, right, and that's given. Okay, right now we have one corresponding part that's congruent. We need to find two more. So step one is write the given. Step two is to look for shared sides or vertical angles. Again, we have a shared side, XY. So XY is congruent to XY by the reflexive property of congruence. Reflexive property of congruence. We now have two corresponding parts that are congruent. Okay, again, I would highly recommend you put the arcs and the dashes in the diagram so you see what you're doing and you see what's going on. Step one, write the givens. We've done that. Step two, look for shared sides of vertical angles. We've done that. Step three is to use our given. So what's our given? That's not a congruent statement. It's the first one. XY bisects. So segment XY bisects angle WYZ. Okay. What does bisects means? It means it splits it in half. It splits the angle. So we're bisecting an angle. This segment is bisecting the angle. This segment is bisecting this whole angle, meaning it's splitting that angle in half. Okay. So if you split that angle in half, so let's draw it out clearly. WYZ, if you split it in half, let's call it this X. Right? These are your two congruent pieces. WYX, angle WYX is congruent to angle ZYX. Right? Okay. Angle WYX is congruent to angle ZYX. We're splitting in half, splitting into two congruent parts. Okay. So we're splitting this angle WYZ into two congruent parts, WYX and ZYX. So angle WYX is going to be congruent to angle ZYX by the definition of an angle bisector. Right? The angle bisector says that an angle bisector splits an angle in two congruent angles. Splits the big angle into two congruent smaller angles. Splits it in half. We now have, let's write it in, right? So this piece is congruent to this piece. And we now have 1, 2, 3 corresponding parts that are congruent. So we can try and prove the triangle's congruent now. Now that we have 3 corresponding parts that are congruent. Well, is this an angle or a side? That is an angle. Is this an angle or a side? That is a side. Is this an angle or a side? That is an angle. So we have 2 angles, corresponding angles that are congruent, and the included side, the side between the 2 angles. So therefore, by angle, side, angle, we can conclude that triangle WXY is congruent to triangle ZXY, which is what we were trying to prove. So I believe that's it for Unit 3. So there will be a 4th part. I'm not going to upload it yet. I'm going to wait until we finish the quiz this Thursday, the Thursday of the week of the 7th. So the January 10th, Thursday, January 10th. And then I will put up the rest. So this is all the stuff I gave you before break, which includes the review for Unit 1, 2, and 3 together. So there will be the 4th unit review added on, plus you will have another review that we work on in class on Unit 1, Unit 2, Unit 3, and Unit 4, focusing mostly on Unit 1, 2, and 3. And then, because we've been most familiar with Unit 4. Okay, so I think that's all I want to say on that.